Hi there, professors. I'm Sun Yue. You can call me by my English name, Sissy. I'm majoring in product design at Shanghai Polytechnic University. I'm also the executive president of the student union, which means I coordinate resources and getting things done. They told me that real change isn't just about a great idea. It's about defining the right problem and making it happen. That's why I'm interested in product design engineering. I know this program includes many science and engineering resources, such as advanced manufacturing, microelectronics in consumer products, and software engineering. My undergraduate design degree is in product design. I'm learning things like internal structure, so I have a good foundation in this area. And my software skills are quite strong. However, my undergraduate courses focus more on problem definition and appearance design. My goal is to work in the automotive interior design, so I hope to deepen my engineering knowledge during my master's to build a solid foundation for my career. And I want to share you about my project. It started with a real problem. China imports over 80% of the soybeans. That's why. Because we don't have enough farmland, so we need smart agriculture. Meanwhile, thousands of abandoned buildings in cities could become vertical farms. At the same time, graduate unemployment is high, and young people don't want to farm. And vertical farm could match your jobs need. I calculate the feasibility. One building produces 1,044 tons of soybean per year, creates 30 jobs, and pays back in 5.3 years. Sketch up, it could replace 30% of imports in China and create 600,000 jobs. Then I develop a detailed design, set selection, building renovation, soybean planting, and AI pest monitoring robots, processing, and even found a low cascade rates for transplantation. The pest monitoring robots was especially important. And my field research showed that pests and disease are the biggest threat to soybean. They can cause up to 50% yield loss in a high destiny vertical farm. It's very difficult for humans to monitor everything. So my robot is essential. I even simulated a vertical farm environment at home and grow soybeans. I study roots, nodal characteristics, and biochemical reaction range, and identify 3 monitoring methods: leaf sampling, soil monitoring, and target sparing. Based on exacting technologies, I complete the functional layout and design. In this project, I identified 3 wicked problems and realized they could be each other's solution. I interrelatively designed the planting rakes, building renovation, and the pest monitoring robots. This is why I love product design engineering here. Product design is driven by research, and everything feels naturally connected. Of course, the robot still has many imperfections, especially in terms of technical feasibility. I want to continue working on the internal engineering challenge of this project during my master's to make it more suitable for vertical farms and to aid human-computer interaction. I hope it can become a breakthrough for soybean farming in China. Designing a real product requires prototyping and engineering research, and my future career needs exactly those skills. That's why I must deepen my learning in this area during my master's time.